Welcome to the Golden Gems podcast. Today we're taking a deep dive into John McCarthy, the father of artificial intelligence and the architect of the cloud economy.
It's great to be here, and honestly, this feels like the perfect time to be talking about him.
It really does. I mean, let's just set the stage a bit. It's 2026, right? Our entire world runs on this multi-trillion-dollar cloud economy, on algorithmic infrastructure.
We're all living inside it.
Completely. We're so obsessed with, the latest generative AI. But the thing is, we're taking the actual architecture of all this for granted.
We are. Everyone's focused on the shiny new thing that can write a poem, but they don't realize we're living inside a blueprint drafted by one guy over 70 years ago.
John McCarthy.
John McCarthy. And here's the real hook, I think. We live in the economic house he designed, the cloud, but we've sort of lost the instructions for the mind he wanted to build.
What do you mean by that?
There's this fundamental battle in his life's work. It's statistical approximation, which is, what all AI is today.
Guessing the next word.
Exactly. Versus logical reasoning, which is what McCarthy demanded. And that tension explains everything.
Okay, so that sounds a little academic, statistical versus logical. Why does that matter to someone just, using these tools?
Because it's the difference between a tool that's just a really good mimic and one that actually understands what it's saying. But before we get into the philosophy, you have to look at his track record. The guy's predictions were, frankly, a little terrifying.
You're talking about the 1961 prediction.
Yes, 1961. He says computing will become a public utility, just like water or electricity.
That's just wild.
He's imagining a world where you don't buy a computer, you just plug into an information grid.
He's basically describing Amazon Web Services in 1961.
He's describing the entire modern cloud.
Yeah.
So to figure out how someone sees the future that clearly, you have to go back to the beginning. And his origin story is not what you'd expect.
No, it is not. He's born in Boston, 1927. His dad is a militant Irish Catholic, and his mother is a Lithuanian Jewish suffragette.
Which is already an interesting mix. But then you find out they were both active members of the Communist Party.
Okay, so that's a heavy political environment for a kid. How does that create a computer scientist?
Well, you can see how it would instill this lifelong skepticism of any kind of dogma, right? He was basically trained from birth to analyze systems to find the structural flaws.
So he was kind of a born contrarian.
A total contrarian. And his family moved around constantly, Boston, LA, New York, so he couldn't rely on schools. He had to rely on books.
I saw that detail about how he learned advanced math.
It's incredible. He taught himself calculus from university textbooks he found that had been thrown out.
He was literally dumpster diving for knowledge.
He was. And then he gets into Caltech, this top-tier school, and he almost immediately gets suspended.
Right, but not for failing. It was
Right.
for PE.
He refused to attend physical education.
You're kidding. He got kicked out for skipping gym class.
And it sounds funny, but it tells you everything about him. He basically told them he was there for pure cognitive labor.
Pure cognitive labor. I love that.
Yeah, he saw institutional rules as just a distraction from the real work, from thinking. It was a rebellion against anything that wasn't pure logic.
And that obsession with logic over, say, biology is what leads to the idea of AI.
Exactly. It crystallizes around 1948 at the Hickson Symposium.
That's where he sees John von Neumann speak.
Right. And von Neumann is talking about self-replicating automata. Now, at the time, everyone else in the field is obsessed with the brain, with wetware, with neurons.
This is the whole cybernetics thing from Norbert Wiener.
Precisely. Cybernetics was all about feedback loops. The argument was, if you just pile up enough feedback loops, like in a thermostat, eventually you get intelligence.
But McCarthy didn't buy it.
Not at all. He had this fundamental problem with it. He said, look, a thermostat has a feedback loop, sure, but it doesn't have beliefs. It doesn't have goals.
It's just reacting. It's not thinking.
He realized if you want a true intelligence, you can't just copy the brain's hardware. You have to formalize the mind's software. You have to build a mind out of math.
And that brings us to the summer of 1956.
Dartmouth College, the turning point. This is where he actually coins the term artificial intelligence.
But why that specific name? It's kind of catchy.
It was pure branding. He wanted to create a clean break from cybernetics. He needed his own territory, focused only on logic, away from all the biological baggage.
So he puts out the call? Who shows up?
It's basically the founding fathers. You've got Marvin Minsky, Claude Shannon,
The information theory guy.
the guy, and Nathaniel Rochester from IBM. The whole crew.
And they get a grant from the Rockefeller Foundation for $7,500.
It's laughable now. That wouldn't cover the snacks at a modern tech conference.
But that $7.5 grand Basically launched a revolution.
Yeah.
Did they actually build an AI, though?
Oh, not even close. Their goal was to solve intelligence in 6 weeks.
Wow.
Incredibly naive. But what they did do was establish the paradigm. They created the intellectual network that ran the field for the next half-century.
So they set the mission. And McCarthy didn't just talk. He went to MIT and started building. This is where we get to the trillion-dollar code, LISP.
LISP, yeah. LISP processor, 1958. It's still in use, which is wild. But it wasn't just a language. It was a conceptual breakthrough. He figured out how to represent code as data.
Okay, code as data. I hear that a lot, but what does it actually mean? Why is it so important?
Well, think of most code like a recipe. The recipe tells you what to do, but the recipe itself doesn't change.
Right.
McCarthy found a way for the recipe to rewrite itself as it was cooking. A program could modify its own instructions on the fly.
So the program can learn, it can adapt.
It's a fundamental prerequisite for learning. If you can't change your own rules, you're stuck.
That makes perfect sense.
And there's another thing inside LISP that we all just completely take for granted now. Garbage collection.
Sounds messy.
It's the opposite. Before McCarthy, programmers had to manage all the computer's memory by hand. You had to tell it when to use memory and, crucially, when to release it.
And if you messed up?
Your program crashed. It was tedious and incredibly error-prone. McCarthy automated it.
You just built a system to clean up after itself.
He created a new layer of abstraction.
Yeah.
He basically said, let the machine worry about the memory so the human can worry about the logic. Every time your phone or laptop frees up memory on its own, that's a concept he invented in '58.
So he's not just building AI, he's building the tools that let everyone else build everything.
He's moving everyone up the stack.
Yeah.
And then he moves to Stanford in '62, founds the AI lab, and that's where the prophecy comes true.
The cloud prophet.
It's cloud prophecy. In 1961, he writes this proposal for time sharing. At the time, computers are these giant, expensive things one person uses at a time.
The old mainframe model.
Right, and he says this is inefficient. Computing power should be delivered like electricity. You don't own the power plant.
You just plug into the wall.
You just plug into the wall. He single-handedly shifted the model of computing from a product you buy to a service you rent.
Software as a service. The entire business model of the internet.
It is. The combined market cap of AWS, Azure, Google Cloud. That is the literal fulfillment of his 1961 paper.
It's staggering.
Yeah.
We're completely swimming in his economic vision. But here's the twist, right? The economy followed his plan, but the AI inside that cloud, it went a different way.
And that's the tragedy. To get it, you have to understand what he thought intelligence actually was. He didn't just want the right answer. He cared about how the machine got the answer.
This is his work on common sense. The paper from '59.
Programs with common sense, yeah. And the idea of the advice taker. He wanted a machine you could give advice to in plain English, not just code.
Like if you drop a glass, it will break.
Exactly. But for a machine to understand that, it needs a model of the world. And this led him to one of the hardest problems in AI, the frame problem.
The frame problem. Can you give us an easy example of that?
Sure. You tell a robot, paint the chair green. It paints the chair green. But in pure logic, how does it know that painting the chair green didn't also change the color of the walls or turn off gravity?
Because it has no common sense about what's relevant.
Exactly. It has to be told what doesn't change when an action is performed. And that's a surprisingly massive, complex problem.
And that ties into another one of his big ideas, non-monotonic logic.
It does, which really just means the ability to change your mind.
Okay.
Traditional logic is monotonic. Once something is true, it's true forever. But the real world isn't like that. You learn new information.
Right. So you learn birds can fly.
And then you learn a penguin is a bird. Suddenly you have to retract your first conclusion for that specific case. That ability to handle exceptions, to retract beliefs, that's what he was trying to build into a formal system.
But the field it didn't stay on that path.
It didn't. In 1973, the Lighthill report comes out in the UK, and it's devastating. It basically says this logic stuff is too slow, it isn't working, and the funding dries up. That's the first AI winter.
And when the field comes back, it's with a totally different idea. It's connectionism, neural nets.
The statistical brain beat the logical mind, and McCarthy lived long enough to see it happen. He watched Deep Blue beat Kasparov at chess.
And everyone else was celebrating.
But he wasn't. He said it won, but it did not understand the game.
It was just a giant calculator.
A brute force machine. And because of that stance, he became this kind of respected but ignored figure. A monarch in exile. By the 2000s, Google's approach was dominant, and McCarthy's logic just looked old-fashioned.
It feels like the whole field made a kind of Faustian bargain.
That's a perfect way to put it. We traded explainability for capability. We accepted a black box that worked, even if we didn't know why it worked.
And McCarthy just refused to sign that deal.
He wouldn't sell hype. He died in 2011, right on the cusp of the deep learning explosion, knowing the field had turned away from his core principles.
But here's where it gets so interesting for us right now. In 2026,
The pendulum is swinging back.
it seems like it. We're hitting the limits of the statistical models, aren't we?
We are. The biggest flaw in every LLM is what?
They hallucinate. They just make things up.
They make stuff up. They fail at simple logic puzzles because they don't understand the rules. They only know the patterns. They're what people call stochastic parrots.
They can mimic Shakespeare, but they have no idea what a sonnet is.
Right. And so now researchers are going back to the vault. They're going back to the McCarthy formalism. We're seeing this huge rise in what's called neurosymbolic AI.
Which is a hybrid.
It's a hybrid. It's trying to combine the pattern matching power of neural nets with the logical symbolic reasoning that McCarthy championed.
So his work is suddenly relevant again.
More relevant than ever. If you want a safe, reliable AI for something like medicine, you can't just have a probabilistic guess. You need to know why it made a decision. His old notes are basically the roadmap for the future.
It's just incredible to think the solution has been sitting in an archive at Stanford this whole time.
It is. He defined the real goal. Human-level reasoning, not human-level mimicry. And looking at our current tools, you have to ask that question. Have we fulfilled his dream? Or did we just build the world's most expensive mirror?
A mirror that just reflects our own data back at us.
With no understanding of what it's reflecting, McCarthy wanted a mind. We built a mimic. And the next decade is going to be all about trying to finally bridge that gap.
Well, he was certainly a mind worth studying. Not a showman, not a hype artist. Just a mathematician who demanded truth.
Truth over performance. And in this day and age, that's a legacy that really matters.
Absolutely. Before we go, we have to give a special shout out to Ivan for requesting John McCarthy. This was a fascinating journey into the DNA of our digital lives.
That was a great request, Ivan. Really made us look at the foundations of everything.
Thank you for listening to the Golden Gems podcast. We'll be back next time with another deep dive. Until then, keep exploring, keep listening, and keep celebrating the power of uncompromising voices.